In section 2.4, in section 2.5, we're going to discuss how to solve quadratic equations. And a quadratic equation is of the form ax squared plus bx plus c is equal to 0, where a is never 0, or otherwise we would just have a linear equation. Here are a few important formulas, and one option for solving quadratic equations is factoring. And so here are a few different ways that we could factor. One is to factor out common factors, or the greatest common factor. And so in this given expression, ax squared plus bx, we see that x is the greatest common factor, and factor that out, and whatever we're left with goes inside the parentheses. So x times the quantity of ax plus b. The difference of two squares, anytime you see an expression of the form x squared minus b squared, you can factor it really easily using conjugate binomials. In this case, x minus b times x plus b. And then if we want to factor a quadratic trinomial, so that is a quadratic expression with 3 terms, okay, we could determine which two numbers multiply to give us c and add to give us b. So in this case, we could get factors of the form x plus m times x plus n, where m times n, or the product, is equal to c, and then their sum is equal to b. And then another very important formula is the quadratic formula, and it is derived using a method called completing the square. So I'll do one example of that in just a minute. It's x equals negative b plus or minus b square root of b squared minus 4ac divided by 2a. Let's take a look at an example. The first equation is 3x squared plus 9x is equal to 30. And because I have 3 terms all together, we will try to factor. But before we do that, we have to get it in the correct form. And that is to move all terms to one side. So make sure that we have it in the form ax squared plus bx plus c is equal to 0. In this case, we have 3x squared plus 9x. Move the 30 to the left by subtracting 30 from each side is equal to 0. I also realize that 3 is a common factor of each term. So if we divide all terms by 3, and that's dividing both sides of the equation by 3, we can simplify. So we have x squared plus 3x minus 10 is equal to 0. And at this point, we're going to try to factor. So we need factors of negative 10 that add to give us positive 3. So how about 5 and negative 2? Okay, so let's just verify. If you FOIL this back out, we should get x squared plus 3x minus 10. And next, we're going to set each of these factors equal to 0. And that's because if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. Okay, so x plus 5 is equal to 0 or x minus 2 equals 0. And then subtract 5 from each side, we get x equals negative 5. Add 2 for the other equation, we get x equals 2. And we see that this equation has 2 solutions. So x equals negative 5 or positive 2. Sometimes multiple solutions are written as a solution set in a set of braces. So -5, 2. And we want to check to see if these answers satisfy the original equation. And so we'll start with -5. 3 times -5 squared plus 9 times -5. We want to see if this results in 30. And that's 3 times 25 minus 45. And let's see, that's 75 minus 45, which is equal to 30. So -5 is definitely a solution to this equation. And we'll do one more. So 3 times 2 squared minus 9, or plus 9 times 2, is that equal to 30? And that's 3 times 4 plus 18, and that gives us 12 plus 18, which definitely equals 30. Okay, I want to show you one other technique for solving this type of equation. It's probably not as fast as factoring, but you can definitely see how it will work. Okay, so the first thing, I would leave that constant on the right, and we're going to do something called completing the square. But I would divide all terms by 3, and that gives us a leading coefficient of just 1. So divide by whatever the leading coefficient is. And we get x squared plus 3x is equal to 10. Okay, at this point, this is where I'm going to complete the square. So we're going to leave a little bit of space, x squared plus 3x, and then we're going to leave a little bit of room plus something is equal to 10. And then whatever we add to the left, we have to add on the right. So our scratch work is we're going to take half of b and square that. And b in this case is 3. So half of 3 squared. Okay, well that's 3 halves squared, or 9/4. Okay, and that's the number that we're going to add in. Okay, well the goal in using the completing the square method is to obtain a perfect square trinomial, which is what we did on the left-hand side. And what this does, it's going to factor as a binomial squared. Okay, so it'll be x and then plus some number squared. And that number, it may be hard to tell in this case. It's going to be whatever the square root of 9/4 is. That'll go in this blank. But if you go back to one of your previous steps, we've already written that number in our scratch work. So that's what I'm going to put. So x plus 3 halves squared is equal to, and then add 10 and 9/4 together, and 9/4 is 2.25, so we get 12.25. Okay, or 49/4. At this point, we take the square root of both sides. And the square and the square root on the left cancel one another out, so we're left with x plus 3 halves is equal to plus or minus the square root of 49/4, which is 7 halves. and subtract 3/2 from each side to isolate x, we get x equals -3/2 plus or minus 7/2. Okay, and this will produce both of our answers. So the first answer, we're going to take the plus, the positive version, -3/2 plus 7/2. Okay, and that's -3 plus 7 is 4. 4 over 2 is 2. And then the other answer is -3/2 minus 7/2. Okay, so that gives us -3 minus 7, or -10, divided by 2, which is -5. And therefore, x is either -5 or 2.